In past videos, we talked about fluids, and fluids move or flow. Now, why do they flow or how do they flow? We're going to take a look at that in today's video. As we begin our video today, we're going to start talking about fluids again and how do they flow. In physics or engineering, we call that fluid dynamics. So basically, why are things moving? Why are they flowing? And the quick and easy example we're going to show today is an aquarium. Say we have an aquarium and for some reason it gets a crack in it or it gets a hole. Okay, it doesn't take a rocket scientist to know what's going to happen. We know that the water is going to start coming out of the aquarium into the area around it. But why does it do it? It has to come back to this very, very simple principle that fluids want to move from areas of higher pressure to areas of lower pressure. Now if we look at the aquarium, all right, let's make sense of this, right? There is water inside the aquarium, and we said that water creates pressure, right? The layers and layers of particles or molecules of water, right, they build up on top of each other. So therefore the bottom layer of water particles have more pressure than the top. So if there's a hole in the aquarium, think about it. Air pressure is going to be a little less than water pressure, so that water is going to want to leave the aquarium and move to an area of lower pressure. Okay, air pressure also has an involvement in this, right? The air on top of the water is pressing down, and that's going to push it out. And we mentioned what causes all this pressure, what causes water pressure, what causes air pressure. It comes back to gravity. So yeah, gravity is going to pull the water out and down, right? And then we have all the other things at play. We have a lot of examples in this video to kind of help us understand that fluids want to move from higher pressure to areas of lower pressure. Now a quick example, again, this is pretty simple. Okay, say we have a balloon here, right? A lovely balloon, and again, think of fluids as more than just water or liquids. Okay, it is also air particles. So say I fill this up with air. So what am I doing is I'm essentially pushing more air particles in here. And the pressure is going to be higher on the inside than the outside. And that has to do part with the balloon and its elasticity, the fact that it's pushing and applying a force to all the particles inside. Alright, so there we have it. So if I release or I put a hole in the balloon, what's going to happen? Right? The air particles inside, right, they have more pressure and they're wanting to go to the area outside the balloon that has less. So if I let go, right, pretty quick and simple, the air went from high pressure, it escaped to an area of low pressure. And it did that without me doing any work. All I did was created an opening for that pressure to exchange. You might think of the same thing if you puncture a basketball, puncture a soccer ball. Okay, the same idea. There's a lot of pressure built up on the inside compared to the outside. A car driving down the road, if it gets a flat tire, right, there might be this explosiveness. It's basically just air rushing out of the tire to go to an area of lower pressure. Our next example is a bicycle pump, right? So I have a large stand-up one here. Let's think about how it works. So we have what's called a piston, right? So our handle is attached to basically a secure ring that pushes the air in. And as that pressure builds on the inside, so there's higher pressure on the inside in the cylinder. So again, I push down the handle, the air inside of here builds up to higher pressure and it's going to escape through the hose, right? If I were to hold the opening, when I press down, right, that pressure builds. If I let go of my finger, right, the air releases from high pressure inside the cylinder to lower air pressure outside. This next example, I have a straw and I have a cup of water. Now, how do you think this demonstrates fluid dynamics? This one gets a little complicated. So, if I were to drink out of this straw, all right, what am I exactly doing? What I am doing is, in my mouth, I'm creating a vacuum, an area of very, very low air pressure. And by doing that, right, I'm sucking in air, and that creates an area of low pressure inside the straw. Now let's think about it. If I'm creating an area of low air pressure, where is the air pressure higher? It's actually higher outside of the cup, right, all the way to the top of the cup. So what's happening is if I create low pressure, right? Water went into my mouth because the air pressure on top of the water is higher, so it pushes the water and it makes it go up the straw. The reverse is the same, so instead of drinking, if I blow into the straw, those of you guys in elementary school that love blowing bubbles into chocolate milk, if I increase the pressure in my mouth and in the straw, it's higher pressure, it's going to want to go to an area of lower pressure. So we end up getting these bubbles. So hopefully you're getting the concept, higher pressure to areas of lower pressure. That's how fluids move at any altitude. All right, my next example here has to do with an air pump for maybe say tubes that maybe I'm pulling behind a boat. So I have one right here, so this is an airhead pump, okay? And the neat thing about it is it shows us a little bit more. It's nice and handheld. So if I look at it, there's an area where air comes in. Inside, if I were to take apart, there's a fan that's spinning. And what does that do? It pulls the air in and creates an area of higher pressure, and that higher pressure wants to escape. It only leaves one way. It leaves out, right, where this little valve is. So this would inflate. So high pressure, it's gonna pump it, or basically the fan's gonna spin and it's gonna make it go the opposite way. So higher pressure inside, and it's gonna be lower pressure right here. Now, if you take a look at maybe a vacuum cleaner, it works the opposite way. Or maybe you've seen a shop vac that it's a blower and it's a vacuum at the same time. It's just depending on where you put the hose. So say this was the hose. Instead of air blowing this way, if I put the hose on this side, okay, what's happening? There's a fan that's pulling, it's constantly pulling. So what's happening is the air wants to go in this way. So all I did was I flipped the side of the fan, right? And you'll see a little diagram here up above that shows you how a vacuum cleaner works, right? It's the idea that the fan is pulling particles, right? So if I'm pulling, right, it's gonna create an area of low pressure right here, because as I turn on the fan, right, as it's spinning, right, if it's taking the particles and moving them, it creates a vacuum or small area where there's no pressure. So everywhere else is going to be higher, it's going to move in. So it's this constant cycle of particles moving towards the fan and then being blown out. Next up, we have a syringe or a needle. And they work the same as the past few examples. Things want to move from areas of high pressure to areas of low pressure. So this thing requires actually some mechanical work. So if you're looking at the syringe, again, we have another piston. So basically we're pulling the top of the needle. And what that does is it creates a vacuum or an area of low pressure inside that needle or syringe. So that means if we put it next to medication, what's happening is that medication, right, is being pushed up that needle by, again, the higher pressure that's outside, and it's going to make the medicine come in. Now, if I want to make a release, if I push on that piston, it's going to build up the pressure inside that needle or that syringe, and it's going to go from high to low. So again, this requires some mechanical work, but it works the same way, right? High pressure to low pressure, whether that's going in or it's leaving it. So this is the same thing maybe as a turkey baster, right? If you've ever seen a turkey baster, right? It basically, we squeeze the bulb, and what that does is when we release it, we're able to suck up the gravy or the juices, and we're able to, squish those out on top of the turkey by squeezing that bulb, and that creates high pressure, which releases it. The last two examples here have to do with a water gun or say maybe a Nerf gun. And again, the whole principle is the same, where things want to go from higher pressure to lower pressure. So here I have a Nerf gun, right? So I pull back the springs. That's basically giving a small area inside where there's air pressure. And by releasing this spring using the trigger, what that does is it releases a spring that pushes these pistons on the inside. And think about it, if that area where air is getting smaller, it's squeezing the air, building up pressure, and that causes these darts to go launching. So we'll see what happens. Right, so there they go, right? Higher pressure to an area of low pressure. The same thing with a water gun, right? When you pump a water gun, what that is doing is just squeezing air, right? When we pull the trigger, it releases the air, which pushes the water out as well. So hopefully this helps you understand the idea that fluids flow. So whether it's air, whether it's water, right? Flow from an area of higher pressure to an area of lower pressure. Now, all science is kind of mixed together, where physics and biology, they kind of overlap. And here's an example of where it's easy to see where physics is involved in the human body. So I have this jar here, courtesy of Mr. Hayes, who retired, right? And I have a balloon inside and I have it attached to a little glass tube, right, and a stopper. And this is going to kind of act as my lungs, right? Now we know, right, there's two lungs, right? In this case, we just have one acting as the yellow balloon. So how do we breathe? Let's think that through. So how do we get air inside of our lungs? It has to do with this principle, higher pressure, lower pressure. So how do we create an area of lower pressure? Now, if we look at our bodies, okay, we have below our lungs, we have a muscle, right, which is our diaphragm. So if I want to get an area of lower pressure, instead of our diaphragm squeezing our lungs together and creating an area where it's high pressure, what it does is the diaphragm goes down in our body and it creates an area of low pressure. If that's low pressure, air from outside my mouth actually wants to go in. So if my diaphragm goes down, creates low pressure inside the chest cavity and the lungs, and air comes into my mouth. If I want that air to leave, the diaphragm pushes up, right, or releases, and that air from in my lungs actually leaves from higher pressure to lower pressure outside. So let's take a look how that would work with this. So first off, I'm going to create an area of low pressure around my lungs. So we can't move the bottom of this jar, but if we did, again, we're just going to create vacuum inside, or an area of lower pressure. I'm going to do that by actually sucking the air out, just kind of like how we would suck out air to get our water up the straw. So if I do that, think about what's going to happen to the lungs. Right, the lung is hooked up to a separate one. I won't actually touch that one. I'll just be actually creating a vacuum on the outside of the balloons. So if you take a look, low pressure outside the balloon, right, actually made the balloon inflate, just like our lungs, right? If the diaphragm starts squeezing up or actually releasing, you're going to see that so I'll release the top here, right, that air is actually slowly leaving the balloon and you're going to start seeing it get smaller and smaller. So how do we breathe? The diaphragm goes down, creates low pressure in the chest cavity, air comes in from high outside to low inside, and then how does it get released? Our diaphragm pushes up and the air flows out. So hopefully you see that connection between the physics and biology. There's tons of examples, but hopefully this kind of helped you get the basics of fluids. We're from areas of higher pressure to areas of lower pressure. Join us next video as we talk about Bernoulli's principle. It still has to do with fluids and flowing, but this has a little bit more to answer the question of how do airplanes flow? Okay, why do things move closer together, farther apart? So stay with us next video and hope you enjoyed today's.